So there are three RISC-V microarchitectures. The first one is single cycle, then we have multi-cycle, then we have pipeline. Single cycle is every instruction executes in exactly one clock cycle. That one instruction came. Okay, you have to understand. Okay, one instruction came. Let's say there are 4 instructions. One instruction come that would execute in one clock cycle all the instruction. That is that one particular full instruction would get executed. Another instruction come that also get executed at a complete one clock cycle. Then the clock cycle must be long enough for the slowest instruction. What does that mean? The clock cycle must be long enough for the slowest instruction. Means if you have 4 instructions, each of these have different execution time, right? They have different execution time. So the one which has the slowest execution time, which takes the not slowest, which takes more executing time, the time taken for execution is more, such instruction, okay, those which take long time. So those instructions, so the clock cycle should be enough for such instruction that which take long time. Such instruction, the clock cycle should be enough. Understood? So the clock cycle should be long enough for such instruction. That is the one which has a more executing time. Okay, simple to design but inefficient. Fast instructions are forced to wait as long as slow ones. So here the problem is that, okay, the thing is single cycle is very simple to design. When we learn single cycle, we will be understanding, okay, after first we'll find it kind of difficult because it's our first time learning single cycle design. But when you find it, you find, okay, single cycle is simple to design. But the problem here is that it is inefficient because the fast instructions are basically the fast instructions so the fast instructions are forced to wait for long, like how slow ones are there, the fast instructions are also forced to wait so long. Example, a simple add and a complex load take both the same cycle time, right? Because both are executing at the same clock cycle. That means both of their time would be same, right? The same cycle time would take. So whether it is fast or slow, the fast instructions are also forced to wait as long as the slow ones, right? That is a problem here. In single cycle, both add and load would take both same time. Add is simple, load is complex because you have to access from the memory and do some things, right? So but both take the same clock time. That is a inefficiency in single cycle, though it is simple to design. Multi-cycle, if you see, each instruction is broken into shorter steps or cycles. Okay, each steps take one shot. That is, each one instruction is further divided into some shorter steps, and each of these steps has clock cycle, short clock cycle given. So simple instruction finish in fewer clock cycle than complex one. This is more efficient, more hardware efficient, because faster instruction would take only less clock cycle because they are simple instruction. So it is much more hardware efficient. Because functional units can be reused across cycles. The functional units like AUs, you can reuse them. Okay, there is reusing is possible. The functional units are able to reuse in multi-cycle. So you have to understand the multi-cycle. Each instruction is broken into different series. Each of these series would actually takes one clock cycle. That is the thing. So if you have simple instruction would finish in how much time? Fewer cycles than the complex ones. Okay. So it's more hardware efficient, is more efficient, and the functional units can be reused again across the cycles. You know, in one cycle itself you may reuse this functional units again. That's the thing. So simple instruction finishes in the fewer cycle than the complex one. Simple instruction means those which is kind of faster, so they require only fewer cycles compared to the ones which is complex. Then we have pipeline. Pipeline applies to pipelining to a single cycle design. Multiple instructions are overlapped in execution like an assembly line. While instruction 1 in stage 2, instruction 2 enters stage 1, and so on. Greatly improves the throughput. Instructions completed per unit time. What does this mean? Pipeline means applies pipelining to a single cycle design. Multiple instructions are overlapped in execution like an assembly line. Multiple instructions are being overlapped here. While instruction 1 is in stage 2, instruction 2 enters stage 1, like that. The instructions are getting overlapped. Multiple instructions are overlapped in execution like an assembly line. We have one student here, another student here, like that. So this, if it reaches stage 2, then this will come in stage 1, like that. So greatly improves the throughput means instruction. Throughput is the instruction which is complete per unit time. The throughput can increase because the instruction which is complete per unit time would be more, because multiple instructions are overlapped during the execution time. So simple instruction can complete faster, complex ones take more stages. That is the thing here. Here in the multi-cycle, what we have is simple instructions will take fewer cycles than the complex ones. That is the only thing, is hardware efficient, because across a cycle the functional units can be reused. But pipeline means what? We are pipelining the single cycle design. In the single cycle design itself, we are pipelining them. How? Here multiple instructions are getting overlapped. The multiple instruction can be executed, overlapped, can be executed together. That's what it's not together, it's like overlapping. Like if instruction 1 is stage 2, then instruction 2 can enter stage 1, like that. That's what it's written here. So because this thing has happened, throughput increase. Throughput increase means that, throughput means what? Throughput is the number of instructions which is executed or completed in that unit of time, per unit time. So we can say simple instructions are completed faster and faster. The complex instruction can take time, can take more stages. Like stage 1, stage 2 is there, right? So in like pipeline, the simple instructions are completed faster. Complex instruction can take more stages. Okay. Through this table, single cycle, multi-cycle pipeline would be very thorough. Like not the concept, what does it means. Here we are only giving an brushing out idea about what would be single cycle, what is multi-cycle, what is pipeline, like that. Okay. Now see this. Single cycle means the cycles per instruction is only 1. Multi-cycle cycles per instruction for a multi-cycle is variable. Pipeline is overlapping. Clock cycle length is long in sync cycle. Multi-cycle has a short clock cycle. Pipeline also has a short. Throughput is low. Multi-cycle medium, pipeline high. Hardware complexity, single cycle is minimum. Multiple cycle is moderate. Pipeline is a complex hardware. Instruction overlap is only happening in the pipeline. Okay.